Hello everyone, today we are going to talk about introduction of spectroscopy. What is spectroscopy? It is basically the study of interaction of electromagnetic radiation with matter. Right, so this is matter, suppose this is matter and this is electromagnetic radiation. So this electromagnetic radiation interact with this matter, right? So after interaction, we do interpretation of this electromagnetic radiation so that we know what type of interaction have taken place here, right? So the study of interaction of this electromagnetic radiation with matter is called spectroscopy. To illustrate more, suppose this is electromagnetic radiation, it's released on matter, so it to interact with this matter. But if we zoom in this matter, right, you'll see there are atoms, there is proton, and there are shells, and where there is an electron as well. So this electron absorbs this electromagnetic radiation. So when it absorbs electromagnetic radiation, so it jumps from this ground state to excited state, right? So basically the electron excited. So the interaction of electromagnetic radiation with matter is called, the study of this process is called spectroscopy. But since there is absorption of electromagnetic radiation by electron, so that's why it is also called absorption-based spectroscopy, right? Alright, so that was what we needed to know about spectroscopy. Now we're going to a history of spectroscopy. It's used for the identification of organic compounds. So before the discovery of spectroscopy, was there any other method used for identification of organic compounds? So the answer is yes. There were classical methods, right? Classical methods. So here we would take unknown organic compound, and the second thing we needed to do is to find what type of element are there. And in order to find that, we used to perform a test which is called qualitative elemental test. What is qualitative elemental test? Well, this test just let us know what type of elements present in a compound, right? So after knowing that what type of element is present, then we had to find how much of that element is present in that compound. So we had to do another test, that is quantitative elemental test, right? So in there we would get like how much of elements, for example, if we have nitrogen which is 100 grams, so how much of it is present in here, right? So from here we would get empirical formula, and once we got an empirical formula, then from there we will find molecular mass. And once we found molecular mass, then we would get molecular formula out of that mass for the compound, right? Well, this math is no longer used because there are certain disadvantages of it, right? Like it was tedious, right, and lengthy process, was not well accurate, wastage of large amount of compound by series of tests, right? So in order to find what type of elements present, how much of it, we used to perform tests like qualitative and quantitative tests, right? So these tests, after performing these tests, large amount of the compounds was just wasted, right? Like if we have a compound of 5 grams, so after performing these tests we would get like 0.5 0.1 gram of that compound, the rest will be just wasted. So it wasn't really effective. So then another technique which is called modern spectroscopy technique was introduced, but it was much effective compared to this classical method. How? Because it was less time consuming, the amount of sample required is less, and although the setup costs of spectroscopy is high, it was very cost effective in long run, right? Also, not much amount of compound was wasted, as it as it used to be in the classical methods, right? So due to these reasons, the classical methods are no longer used, but now the spectroscopy is used, right? Now come back to our main topic, spectroscopy, as we also already defined what is it. It is the study of interaction of electromagnetic radiation with matter, right? But the interaction could be of many types, like for example, if this electromagnetic radiation we release and it interacts with this matter, right? So there could be emission, there could be transmittance of the radiation, there could be absorption, scattering, reflection, which means some light, some radiation will reflect back, and absorption, where some could be absorbed in that matter, right? So here we are going to just talk about absorption and emission as it is most important, right? So on the basis of interaction, two types of spectroscopy. I mean, we have two types of spectroscopy and the basis of interaction, that is absorption and emission. What is absorption spectroscopy? Well, electron present in an atom or molecule of the matter absorb energy from electromagnetic radiation falling on it, right? So they jump from the ground state to excited state. So this phenomenon is called absorption, and the study of this phenomenon is called absorption spectroscopy. For example, you can see in this diagram, here we have ground state, while this is excited state and this is electron. Ground state is represented by Eg, or you can say E1 and E or E2, right? So this electromagnetic, when falling this electron, it absorbs this electromagnetic radiation, and it jumps from this ground state to excited state, right? So this is called absorption spectroscopy. Now here's the thing, that what molecule would absorb electromagnetic radiation? So those molecules can absorb electromagnetic radiation which has non-degenerated multi-energy states. Now what is non-degenerated? Non-degenerated energy states means different energy states. It means the molecule must have different energy states to absorb electromagnetic radiations. Now energy states could be of four types: electronic energy states, vibrational energy states, rotational energy states, spin energy state, right? So the first one, that is electronic energy state, right? So here it has ground state and excited state, which is represented by E1 and E2. The same here is vibrational energy state, right? It has ground and excited state represented by V1, V2. The same goes for rotation and spin energy state, right? Now here what we need to do is to excite electron from here to excited state. But how? By giving energy from where? From electromagnetic radiation. But we know that electromagnetic radiation could be of many types, like it could be gamma rays, it could be X-rays, UV visible rays, IR, microwave, radio waves, right? So the most powerful and energetic is gamma rays, right? And the most least energetic is radio, but the wavelength of radio wave is greater than amongst all, right? While its wavelength is lowest amongst all, right? So it is more powerful. It could penetrate up to nucleus if it is exposed to the atom, right? While X-rays, it is a little less more powerful as compared to gamma rays, but it could reach up to the inner electron in the atom, right? And then when you talk about, then next ray comes UV visible rays, which could excite outer electron, right? So here it could be used in order to excite electron from ground state to excited state, right? So UV visible radiation is used in order to excite electron from ground state to excited state, and we study this whole process in UV spectroscopy, right? Okay, then there is IR radiation. IR radiation could cause molecular vibration. So here we have vibrational energy state, so this IR could be used here, right? So we studied this whole process in IR spectroscopy. The next one comes microwave. Microwave could cause molecule rotation. It could cause molecular rotation, right? So it could be used here. Microwaves could be used here, and we use this in microwave spectroscopy, right? And the next one is radio wave. Radio will cause nuclear spin flipping. This is nuclear spin, right? So if you use radio wave, it would cause nuclear spin flipping, and we studied this in NMR, right? So this is all about absorption spectroscopy. Now we're going to talk about emission spectroscopy, what it is. Okay, what is emission spectroscopy? When an electron present in an atom jumps from excited state to ground state, they release electromagnetic radiation. This phenomenon is called emission, and the study of this phenomenon is called emission spectroscopy. Suppose this is ground state and this is excited state, right? Electron jumps from here to ground state, right? And they release electromagnetic radiation, right? So this is emission, and the study of this whole process is called emission spectroscopy, right? So this is all about what is spectroscopy. It was a basic introduction of spectroscopy, and I hope you understand everything I say. And if you don't understand, you can ask questions in the comment section. But if you like my video, please like my video, give a like, and also please subscribe my YouTube channel. This is my first video, so don't discourage me, please.